All right, let's continue on with the vertical curve design. Having got your natural surface long section done, we're now going to be looking at the grades, designing the road and the vertical curve calculations and through to your submission. First of all, plot your starting point RL. Here it's 24.5. And what we now want to do is to find grade lines which follow the natural surface as closely as possible while meeting the cut and fill specifications. And so it's a lot easier if you use a transparent scale or set square. So you can get a feeling as we run the set square from the 24.5 at 0 up through there. Yeah, look, one straight grade. As a trial, we'll go to exactly to the highest point, the 33 metres at chainage 140. So let's have a look at where we go after that. If we were to treat that as our first IP, we could try going straight to the river, but that's going to be a lot of cut. That's far too much. That's not going to work. So it looks like from our first trial IP, we'd need to have another grade that follows the natural surface as the red line does through to around about the chainage 223 mark. All right, from chainage 223, we can see from the set square that the ground level slopes pretty uniformly, and we can get one grade through from down to the river. So basically the design decision is for the first three grades, in general terms, there'll be one grade that goes from 0 to around 140. Then from the second one goes from 140 to about 220 or 230. And then from wherever we decide to put it at 220 or 230, down to around the river, around the 410, 420 mark. Remember that every IP for your vertical curve must be located at a 10-metre interval of distance. So that's why I've been saying 220 or 230, 240, 220. We'll work that out later on. Okay, now we need to start doing some calcs. Remember the formula for grade. Grade is the slope of the road. So grade equals rise over run, which is another way of saying the change of height divided by the horizontal distance. We multiply that by 100 over 1 and call it a percent. So for the first line, we're starting at 24.5. We're climbing up to 33. So the delta H is 33 minus 24.5. The horizontal distance is 140. So that gives us a grade there of plus 6.07. Working through the second and third grades, we get minus 3.6 and minus 9.4. Now at this stage, it's worthwhile just scribbling these out on a sketch bit of paper as we start to think about how we're going to join these and smooth these out with vertical curves. Now look, normally you'd only have to worry about one vertical curve smoothing out the transition from one grade to the next. But because these two intersection points are close together, it's worthwhile looking at the two of them together. So a couple of things to think about. How far below the intersection point will the road end up? Look at the red arrow. The whole aim of a vertical curve is to smooth it out so that cars don't have to go all the way to the peak. So the road is going to end up being some distance away from the intersection point. The other thing you need to keep in mind is that because these two IPs are quite close together, the vertical curve lengths may need to be selected to make sure that the two vertical curves can fit together and they must never overlap. They can abut, they can have a common tangent point, but vertical curves must never overlap. So we need to start looking at the geometry for the vertical curve. And the critical thing, the only thing we're going to worry about now is calculating the mid-ordinate. That's that red arrow on the previous diagram. The distance from the intersection point down to the curve directly below or sometimes above the intersection point. You can see the formula there, OM equals L times G2 minus G1 over 800. So for the crest vertical curve, we've got a plus 6.07, meeting a minus 3.6% grade. So G2 minus G1 is minus 9.67. So that's fixed, the 800's fixed. The only thing that's going to change is L, the length of the curve. You're allowed to use either a 60 or an 80. Special circumstances, you could put a 40 in, but let's aim for 60 or 80. So OM for a 60 is minus 0.72. OM for an 80 metre curve would be minus 0.97. So remember that the OM is the distance the road is below the intersection point. 0.97 is getting very close to 1 metre. We'd aimed our first IP at being exactly at the highest point on the ground, so then our road's going to become very close to being down at the level of the maximum cut allowed. It'd be nice to give ourselves a little bit of wriggle room. There's two ways to do this. We could shorten the curve. That means that gets a smaller OM. The alternative would be to raise the intersection point by lifting that first grade, making it a bit steeper. Purely up to you. You're the designer. You can choose one or the other, or even both. From my point of view, because a longer curve gives you greater line of sight over the crest, I'd prefer to use an 80 metre vertical curve. So I decided I'd like to lift the grade, make it a bit steeper. So as a first guess, I'm going to try, let's say 6.3%. So 6.3% times 140 gives me a rise of 8.82 metres. So the RL of the new IP would be 24.5 plus 8.82. That's 33.32. So we know our OMs are around about a metre, working in rough figures. So that means our road will now be at about 32.35. So that gives me about 0.35 of a metre to be inside the maximum depth of cut allowed. All right, now let's have a look. Would an 80 metre work? We can't overlap, remember? So if the first IP is located at 140, then the finishing TP of this is going to be at the IP chainage 140 plus L on 2. So 140 plus 40, that equals 180. So that leaves me room for the second vertical curve to be at 80 metres, because 180 plus 40 gives me 220. So as long as the IP of the second curve lies at 220 or greater, I can fit two 80 metre vertical curves together. So I've decided I'm going to adopt 6.3% as the first grade. So now we can start on the maths. The first thing you need to do is to find out what are the points where you need to work out the design RLs. We're asking for you to do it every 30 metres on the grades only, and then every 10 metres inside the vertical curves. So we start off 0, 30, 60, 90. Then we hit the first tangent point, 100. So we go 110, 120, 130, 140, 150, 160, 170, 180. We've now finished that first vertical curve. So get these numbers right, then put them onto your answer sheet. Write in the 6.3% somewhere down along midway through that line, and put a line on your sheet at 140 to remind you that that's where the grade stops. Put that line right in the middle of the square. Don't put it on the line above or below 140. Then you're not sure whether it's at 130 or 140. You'll get yourself and the markers confused. So put that line right in the middle of the box on the 140 line. Calculate the grade levels through. What we now find is that the grade level at 140 becomes 33.32. So going on for the next point, to find the next grade, we are going to have it located at 30 at chainage 220. So that now gives us a minus 4.15%. Now this is different to what we had before. So you need to go back and recalculate your first OM just to make sure that the road will still fit inside the maximum 1 metre cut. And sometimes this happens, that design is an iterative procedure. You start doing some calculations, make some decisions. Sometimes you've got to go back and make some adjustments. Okay, so mathematically we've locked in the grade as the grade's been found to be minus 4.15%. To make life easy for you as the designer and also for the road builders, we don't quote grades to more than one decimal place unless it's absolutely necessary. So once again, you make the decision. Are we going to make it minus 4.1 or minus 4.2? Because we're living in the real world, not in calculator world. So make life easy for the road builders. Their equipment probably only works to one decimal place anyway. So trying to sort of have them find grades to 2 decimal places, they're going to say, well, which people are gravel do you want to measure it on anyway? So have a quick rough check on the second VC. It's got its IP at 220. If we're working again with an 80 metre curve, we've got minus 9.4 minus 4.1 times 80 over 800. So that's only minus 0.53. So an IP close to the natural surface won't cause any problems with cut. So fill in the next grade, the minus 4.1%. Work your way through calculating precisely all the grade levels. And you notice that when you get to 220, the grade level is now 30.04. We were aiming for 30, but because the mathematics is coming out a bit differently, it's now 30.04. Use what the maths gives you. It's close to what you aimed at. That's great. That's fine. If it was a bigger gap, look for some error, but you must trust the maths. The plot on the graph is a guide only, and the maths that you calculate must be true. Okay, so you repeat this procedure, working through finding the trial grades, finding the set square to follow the line, and you repeat this procedure down through the river and back up the other side until you get to your last vertical curves intersection point, which is IP4. Now its RL and position has been fixed because you started at your RL over at 0, 0, which is fixed for you by your data. Your grades and your distances have now run it through over the length of the road. And so the RL at IP4 is absolutely fixed, cannot be changed. The RL of the parking area is also fixed by the specifications, so it can't be changed. So the grade of that red line, the red dashed line, that's going to join IP4 to point P must be calculated and shown precisely. Potentially to 2 decimal places, that should be sufficient unless the line was very long. And this is the one case where you can show the grade to more than 1 decimal place because the mathematics inside your calculations must always agree perfectly. So now that the grades are fixed from start to finish along the road, you now come back and start to do all the precise vertical curve calculations. So far we've only been worrying about rough mid-ordinates to check that the road's going to meet cut and fill requirements. Remember, it's always best to do all calculations of RLs and ordinates to 3 decimal places and only round off at the very end when the design level's being calculated. So you can see here we've started to fill in the OM and the PQ values all the way through. It's a good practice always when you're starting. Immediately put a 0 in on the tangent point lines. You can see at 100 and 180. So that reminds you there are no ordinates outside of the vertical curve calcs. Remember that X is measured in from the tangent point. So the ordinate 110, 10 metres in from the first TP, is exactly the same as the ordinate 170, which is 10 metres in from the second tangent point. Similarly for 120 and 160, and 130 and 150. So now you add the ordinate to the grade level and fill in the design level. Where there's no vertical curve, the grade level is the design level, so fill that in. Round off in the design level to 2 decimal places, which is fine for road construction. So the question becomes, what would you do if the answer to 3 decimal places ends exactly in 0.005? A good rule of thumb that I think is worthwhile following is always round off to the even number. So 31.365 would become 31.36. 32.015 would become 32.02. And if you use this rule, it means some numbers are rounded up, others are rounded down. So this randomizes the process and avoids having systematic errors if you always just round in one direction. You need to calculate the change and RL of the low point on your sag vertical curve. And once you've calculated all these design levels, you should plot each point within the vertical curve and smoothly join the dots to show the curve. Also plot the change and RL of the low point, making sure that that plots on the curve. This is a fantastic check of your calculations because each point should plot on a nice smooth curve or obviously on the straight grade. Now, while 40-metre vertical curves are generally not allowed, there may be a case where you need to fit two VCs close together. If this should happen, you need to point out this situation to the client or / your marker. Then you need to complete the long section as per the example in the next slide. Okay, a lot of information needs to go here. You need to plot the road. It's okay to leave the grade lines through, and a vertical line should be drawn at each IP from the baseline up to the IP. You need to write the IPRL and the mid-ordinate at every IP, either above or below the natural surface as space permits. I just highlighted 2 of the 4, one's below, one's above, because that's where they fit. You need to nominate the vertical curve lengths. You can see this has been written, that the dimension arrows go 2 lines above your baseline. Put dimension arrows and the length of the curve should be written in. So you can see they're 80 VC, 80 VC, 60 VC, 40 VC. You need to show your grades. These go 1 line above your baseline. So you can see the dimension arrow shows that 6.3% goes from 0 through to 140. Then you've got minus 4.1, and the dimension arrows will show through there. So that's absolutely critical to show that. Down in the written part, to avoid complications and because you've got the table done, we're only wanting you to mark the distance and design levels at each vertical curve IP. Write IP down below the line, please. Fill in the chainage and also mark in the design RL. Now, often because your IP maybe end up very close to a natural surface level, as you can see 220 and 230, it's okay to slide the 220 and the 29.51 aside a little bit, just for clarity, but the point, the vertical line, has to be plotted precisely. Okay, finally, any instructions for the survey party? There was the area around change 140 where the height of the ground from the contours was not very reliable, so you'd ask them to set out the curve and take some levels there. Think about, are there any critical points on the long section where you might not trust the contours? You need to be specific. Just survey the lot isn't going to cut it. So give a brief explanation as to what you think the problem area is and why you need that data. Submission. Complete your answers in the Word file in the spaces provided. Please scan or photograph your copy of your completed plan and long section. Then copy and paste them to the end of the Word answer file so that all those items are submitted to UTS Online as one file. I hope this has helped you with working your way through it. Good luck with it. Go back over this casually and take your time to read it through carefully.